so lonely. If you're leaving, baby, let me down slowly. Let me down. Let me down.
So, Assalamu alaikum. Dear students, once again welcome back to my channel. Education is the key to success. Oh, sorry. Now it is not education is the key to success. Basically, it is a quote that was motivation to start with, but now I've moved on and my channel name is changed to Brain Gain, as your brain is gaining something from my channel and it will be in future, so I will continue to do so, that your brain learns whenever you come to my channel Brain Gain. In our motive is, you can say the slogan is, the more you share, the more you learn. Okay, so today's lecture is on, as the title will tell you, but before going on to that, I have a small request to you, that it is seen that the public who came to channel in the past is that public who have not subscribed the channel yet. So I will request to all of you, so please take 2 seconds and just press that subscribe button, just because it will be a motivation for us to do work and continue so. So it's my request to you, please. Okay, so I'm going to start with the differential equation course again. So it says lecture number 6, that was missing in between. What we are going to do, we are going to solve the example for exact differential equation. Okay, basically what we are going to do in example, that is to find m of xy, that function. Well, given and it is given that the equation is exact differential equation, and we have studied in previous lectures the conditions for the exact differential equation. So find m of xy such that we have an equation m of xy dx plus x into e to power xy plus 2xy plus 1 over x, and it will be dy, and it is equal to 0. So this is this equation is exact differential equation. So what we know, that in the exact differential equation, the function with dx is mxy and the function with dy is nxy. So we have nxy, and that is x into e to power xy and plus 2xy and plus 1 over x. So the condition to prove the exact differential equation is that partial m over partial y is equal to partial n over partial x. To prove the equation to be exact differential equation, we need to prove this one equation. So I will take its partial derivative with respect to x and make this side, and by having this side and letting it equal to this side, we can find out our m of xy. Okay, so we will continue that. So taking the partial derivative, partial n over partial x is equal to, it is the product rule will here apply. I will taking the derivative of x, that is 1, and e to power xy as it is, and then plus x as it is, and e to power xy ka derivative, that is e to power x, and in the power ka derivative, x ka derivative is 1, and that will be y. Okay, then plus 2 y is constant, and x ka derivative 1, plus 1 over x ka derivative is minus 1 over x. Okay, you have done it so in your past in your FSC course, so I am just letting take directly that one. Okay, so I will just simplify it. Partial n over partial x is equal to e to power xy plus xy e to power xy plus 2y and minus 1 over x square. So this is partial n over partial x. So we know that the partial n over partial x is equal to, you can basically the partial derivative of n is equal to partial derivative of m, but n has the partial derivative with respect to y, and n has a partial derivative with respect to x. So due to not enough space, I'm just going to erase this one, and you know the expression we have. So we know that partial m over partial y is equal to partial n over partial x is equal to, what we got, the factor at last is that y e to power xy plus xy into e to power xy plus 2y minus 1 over x square. So I will let this partial y to go here. Okay, that is partial m is equal to e to power xy plus xy e to power xy plus 2y minus 1 over x square. So after that, and here is your partial y. So now I will integrate this, and it is a partial integration, so and it is going to be integrated here with the respect of y, so x will be treated as constant. So integrating with respect to x, letting integrating with respect to y, letting x constant. So that will have these signs. 1 dot partial m is equal to integration e to power xy plus xy into e to power xy plus 2y minus 1 over x square, and this one as this partial y. So you know the partial derivative of this will be m of xy is equal to, so having that you will get that e to power x, so it will be as stated as e to power xy, and this term derivative will be in the division derivative with respect to y, so it will be just x. So this was, and now the same one plus xy into e to power xy. So here we have the product, and you know what rule is treated. We will take the x common, and then we will treat this part by Eilert rule. Okay, so what is Eilert rule? Inverse logarithmic arithmetic. So we have y as arithmetic and this one as exponential. So this one is going to be treated first, this one going to be treated at last. So what we do, the thing which is going to be treated at first, that is y, the arithmetic function. So we will have to take its derivative. Another one is to be deal with integration. So what we do, we take that part which is going to be have derivative as it is, and the integral one to be have integration done, e power xy over x, and the minus one integral, and the derivative to be taken is taken, and again integration is to be done here, and with the partial y, and again plus 2 y square by 2 and minus 1 over x square y. You know how the integration takes place, and when we end the integration there is some constant, but still we have a part to evaluate with the integration. So we have m of xy is equal to e power xy over x, plus this x will be multiplied inside and this will cancel by this thing, this will be y e power xy, and then minus this x is cancelled by this x, and then we have again the integration of this one, this is cancelled. Okay, then we have again integration of e power xy over x, plus 2 is cancelled, then we have y square, and then we have minus y over x square. Now the integration is done and we need a constant. So here what is constant? X. So x is constant, so you may have the other function which is constant in terms of x, g of x. G of x is some function in terms of x. So what we have, m as e power. So here you can see that this time is going to be cancel. So we have y into e power xy minus, it's not minus, plus y square minus x power minus 2 into y plus g of x. So this is your m of xy. And if I want to say, if I say you that to prove this, that this is your good one answer. So this, the partial derivative of m with respect to y should be equal to this. So should we take? Okay, we will take that and we will prove our answer. So what is our m? You already know. I will just start by taking its derivative with respect to y. So partial m by partial y is equal to, okay, we have the first m of xy, and that is equal to y e power xy plus y square minus x power minus 2 into y plus g of x. Now I am going to take partial m by partial y, and it is equal to, this will be treated as product rule, that is y derivative 1 e power xy as it is plus y e power xy derivative, that is again x, minus x to the power minus 2, and g of x with respect to y, its derivative is 0. So we have partial m by partial y as e to the power xy plus xy into e to the power xy minus 1 over x square. And if you remember, it is exactly the partial n by partial x. So partial m by partial y is equal to partial n by partial x. So your answer is verified, that it was given that this equation is differential equation, and we have proof. So our answer is what you have learned here. So guys, this was for today. So thank you for watching. May God bless you. And at the end, I will again request to please subscribe my channel. May God bless you. Allah Hafiz.